Okay, I want to today to introduce you to the concept of regression and show you how you can do it using Desmos. This is also, these are kind of synonyms of regression and the curve of best fit. You can think that, okay, maybe we would study a relationship between two variables, like a person's height and their shoe size, something easy like that. And if you asked everybody their height and shoe size, you would get each dot would represent a person, and you would tend to see that the taller people are, the bigger their shoe size is. Now, it's not always perfect, right? But in general, the taller people are, the bigger their shoe size. And if you used Desmos or a graphing calculator, you could come up with what's called the line of best fit. So it will help you generate, I'm just sketching this now, right? It would help you generate an equation of a line that would really generalize this data. My printer's running for some reason, so it's a little loud in here. It would generalize the data. So we could come up with what's called a line of best fit. Now, other data doesn't come in a linear form, but it might take a different shape. So for instance, if you had time since the punt, like you're punting a football, how much time has passed in seconds, and then the height of the ball. Okay, so if you were looking at the time and the height, you would notice that as time passed, right, and we're talking about just a few seconds here, the ball would kind of go up and it would reach a peak and then it would come back down again until it was back on the ground. And this isn't a line of best fit, right? I don't want to put a line on these data. I want to find a curve that will fit, right? So I want to have Desmos or a graphing calculator come up with an equation of a curve, a parabola, right? That's going to fit this. So that's what we're working on today. We're going to take some data and we're going to graph it, and then we're going to have Desmos calculate the equation of the line that fits the data as well as it possibly can. Okay, it may not fit perfectly, but it's going to be a pretty good fit. Now, I have also posted this. This paper itself is posted as a PDF, so if you have a printer and you want to print it out, you can. I've also posted this. These are the directions that you can use. I'm going to be going through these directions, but you can use these directions to help you when you're using Desmos if you kind of forget some of the steps, okay? So the first one that we're going to do, we have a study that compares the speed, and that's in miles per hour of a car, and the fuel economy, like how many miles per gallon you could get, okay? So this is the fuel economy, and you want that number to be higher, right? Because if you have a higher fuel economy, that means your car uses less gas. And here are the results. And what we're going to do is we're going to take the data and we're going to put it into Desmos, and we're going to have Desmos come up with the equation of the curve of best fit. Okay, so to do this, I am going to be following my own directions here, but I can't show you the directions and Desmos at the same time, so I'm going to switch over to Desmos so you can see. So for this, you don't go to student.desmos.com, you just go to desmos.com, which is the graphing calculator. And most of the work that we do with Desmos, we do in this main screen. Like if you wanted to graph an equation, you would type y equals 3x squared or something like that, squared, right? We're not going to work in this. We're going to work in a table. So you have to go up here to the plus sign and click table, right? And it gives you a table where you're going to enter x1 and y1. Okay, so all of my x values are all of the speeds. So I'm going to enter as quickly as I can all of the speeds. These are in miles per hour. Oh, look how smart Desmos it is. It already knows what I want the next one to be. It found the pattern. Okay, awesome. And then I'll go back up and I'm going to enter all of the fuel economies. Those are all my Y values. Oh, and I got to make sure I don't mess it up. This I'm taking from the data set on the worksheet. Okay, so I've entered all of the speeds. These are in miles per hour, so like 15 miles per hour, 30 miles per hour, 45, and all of the fuel economies, right? How many miles per gallon you would get if you were driving at that speed. Now, what you don't see are any points on the graph yet, and that's because we're looking at just all these numbers are off this grid. So what I want to do is go in here and I'm going to adjust the graph settings. And I can do a lot of things in here. For one, I can label the axes, which might be a good idea. The x-axis represents speed in miles per hour. Whoops, miles per hour. And the y-axis represents the fuel economy. Fuel economy in miles per gallon. Okay. And what I'm noticing is that my x values go all the way up to 70. So I'm going to change my x-axis to go from 0 to 70. And I notice that my y values are all less than like about 30. So I'll change my y-axis to go from 0 to like 35 or something like that. Okay, now I actually see the points. And I hope that you can see that they don't make a straight line, right? They make kind of a curve. And so what we're going to try to do is we're going to ask Desmos to figure out the equation of the parabola that's going to go kind of go through these points, or it's going to fit them as best as it can, the curve of best fit. It's not going to intersect every point, but it's going to look pretty good. Okay, so the way that you do that, again, this is also in the directions, right? To find a quadratic regression, we had to put in the data, and then I'm going to type in this equation. I'm basically typing in the standard form, ax squared plus bx plus c. But instead of y equals, right, I have to use y1. That's because up in the table here, it says it's y1. Okay, I have to use y1. And instead of using an equal sign, this is the one tricky part, instead of using an equal sign, I'm going to use this little curve. Okay, and it's above the tab key. It's under the escape key on your laptop. So on the like right next to the number 1. That's how I get that little symbol. And then I do a x1. Again, I'm not using x. I have to use x1 squared. See, I need squared plus bx plus c. Oops, I messed up. bx1, right? So everything, instead of using x and y, I have to use x1 and y1 because that's how this chart up here is labeled. I can't use x and y, x1 and y1. Okay, so look at that. That looks pretty good. What Desmos did is it came up with a curve, right, that goes right through here, and it generalizes these points. And if I want to know what the equation is, I can use these numbers here to write the equation, which is what I'm going to do. Okay, so I'm going to bring up my paper here so I have it on the same screen. Because now I can go and I can actually use this information to answer the questions. First, write the equation of the curve of best fit and round all the numbers to 3 decimal places. So basically what I'm doing is I'm writing an equation and I'm putting in the a, the b, and the c. So negative, that's a, x squared. Remember, this is every equation looks like this, ax squared plus bx plus c, every quadratic equation. That's standard form. So I just put the a here, and then I'll look and see what b is. B is 0.746, I got around that. And C is, I'm just looking right over here, 13.472. Okay. Next question is, according to the graph, what is the best speed to drive to get the best fuel economy? Well, the best fuel economy, right, is the one that's the highest, right? The best speed to drive is the best, has the best highest fuel economy. You want your fuel economy to be high so you don't use a lot of gas. And this is the highest point, right? The best fuel economy would be 30.4, and that would happen if you were driving about 45 miles per hour. So that's the speed that you want to drive if you want to get the best fuel economy. And that's actually true. This isn't a made-up problem. That's the best speed for fuel economy, is to go 45. So I'm going to write that down. Best speed for fuel economy, 45 miles per hour. Now, there's one other bit of information here. Besides A, B, and C, we're also given a number called r squared. And at the bottom of this page, I kind of explain what r squared means, okay? What the r squared value is, it tells you how well the regression model fits the data. So this is pretty good. If you look at this graph, I mean, it's not going through all the points, but it's pretty close to all of these points, right? There's no points that are really far off the curve, right? So I can kind of look at that and see. It's always going to be a number that's between 0 and 1, and the closer it is to 1, the better it fits. So if you find an r-squared value that is 1, then you know that the data is actually going to all be on the line. It's perfect, right? It's a perfect fit. So if you're ever trying to just choose, you always want to pick the r-squared value that's closest to 1. So when I look at my r-squared value here and I see that it's 0.9646, that is really close to 1, right? That means that the data really fits this curve. It's a very, very good fit, okay? The line that Desmos came up with, or the equation, I guess, that Desmos came up with, okay? All right, we're going to try another one. Get my paper out. All right, so the next one says a pumpkin tossing contest is held every year in Morton, Illinois. People are going to compete with a catapult to see who can send the pumpkins the farthest. One catapult launches pumpkin from 25 feet above the ground at a speed of 125 feet per second. Okay, the table shows the distance that the pumpkins will travel when they are launched from different angles. So this is the angle of the catapult, and this is the distance that you can get the pumpkin to go at those different angles. Okay, so again, I'm going to go over here to Desmos, and I'm going to enter this data because my angle is going to be x and the distance is going to be y. So I would encourage you, instead of just watching this one, please go to Desmos now and you can enter this data. Okay, go to Desmos yourself and enter the data. It's hard. I know it's going to be hard for you guys because unless you have the paper printed out, you might have to go back and pause the video so you can do it. Let's see, I need a table. Oopsie. Just get rid of that one. Start over. Okay, so on this one, I need to change my axes because this isn't speed anymore. This is the angle in degrees. And the y is the distance. And I see that my x values go from 20 to 70. So actually that's okay. What I have down here is okay for the angle, but I definitely need more on the y-axis. So my y's go all the way up to over 500. So let's go from 0 to like 600 so that I can see all the points on the graph. Okay, ooh, these look great. Now, again, I'm seeing that curve, right? That kind of U-shaped graph. This is going to be another quadratic regression. So I'm following the directions here that are on the paper, and I'm going to type in the same equation. Oh, I did it again. Y sub 1 equals. I got to use y sub 1. And I got to use this little symbol instead. Good thing I have my directions here. Got to use that symbol instead of an equal sign. X1. And make sure my formula is right. Okay, so what I would like for you to do is to use the information here to select which of those is the correct equation of this curve, the black line. Which one is the equation of the black line? Okay, so we're going to use A, B, and C to help us build this equation Just like the first one, it takes the form ax squared plus bx plus c, right? And I'm using f of x instead of y equals. It's essentially the same thing. But I'm going to use negative 0.261 x squared and I'm rounding to 3 decimal places. That's the nearest thousandths place. Okay, so I just took a, b, and c over here from the parameters, a, b, and c. Notice that the r squared value is really close to 1 again, so it's a very good r squared value. And now, based on my prediction in part B, I guess that should be part A. I'll change that. Based on my prediction in part A, my equation, predict the distance a pumpkin would fly. It was launched at 15 degrees. Okay, so let's go over, this is what's cool about Desmos. Let's go over to Desmos. Notice that one of the things that you can do is you can just drag your cursor along this line, right? So in every case here, the x value represents the angle and the y value represents the distance. So I want to just wander down here to 15 degrees. Let's see if I can get it exactly there. Maybe not. There it is, 15 degrees. And let's see what the distance is. So that says if it's going 15 degrees, if I launch at 15 degrees, it will go 303 feet. So if I launch it, I'm just clicking on my graph to find that out. Launch at 15 degrees, it's going to go 303 feet. If you want to win the contest, having your pumpkin go the farthest, which launch angle should I use? Okay, so the farthest distance is the top of this peak. So another nice thing about Desmos is if you just click near the top, it will tell you what the highest point is. The farthest distance is 511 feet, and you will achieve that if you launch at 43 degrees. So I can answer those questions. 43 degrees. Okay, so the graph, this is nice on Desmos. You don't even need to you're not going to have to plug into the equation, right? Because you can just use your cursor and just kind of scroll along here to find the points that you want. Okay, we're going to do one more. And this last one is more for you to do. Meteorologist table here predicts the temperatures for an October day in Sacramento, California. My hint is when you enter the data, make sure you're using military time. So instead of 8, 10, 12 a.m., we're going to make 2 o'clock 14 o'clock, right? This would be 16, and this would be 18, okay? So what I would like for you to do is to go enter the data and then select the correct equation. So go to Desmos. Your job is to enter the data. These are your x values, and these are your y values, and then select the correct equation. Okay, I'm going to change my graph a little bit to make it a little easier to see. This represents, x represents time this time, and y is temperature. My times go from 0 to, let's do a full day, 24 hours. And my temperatures don't go all the way up to 600. Let's just go to like 100. Okay. Now I can see the curve a little bit better. It's going to be another parabola. And I'm just going to take this equation. I guess it has to be underneath. I'll just rewrite it down underneath. I'm going to write the equation here. y1, use the little thing, a x1 squared plus bx1 plus c. Okay, I had to figure out what was going on here. Notice that somehow it changed to x2 up here, so I'm going to go back and change these to x1. Then it's going to work, and y1. Now I have a nice curve. Okay. So my equation then, I'm going to use those coefficients. Write it out. My equation is negative 0.469 x squared plus 14.716x minus 36.121. I'm rounding all those. Next question, what's r squared? So look at your information. R squared value is 0.992. How good is my r squared value? Well, it's really close to 1, so I would say very good. It's very close to 1. Okay, finally, last question for you. Use your equation of best fit to make a prediction about what the temperature is at 11 a.m. So make your prediction. Use your graph. Use the fact that you can drag your cursor across the graph. Make a prediction. What I'm going to do is just drag through here until I got to 11. Oh, that's really close. That's close enough. Let's just call it. It looks like 68.993. That looks like 69 degrees at 11 o'clock. Okay, so we go back, 69 degrees. Oh, it's not going to bring my paper up. Oh, there it is, 69 degrees. Okay, so that's just a little introduction to how to do the regression. Next class, I believe, we're going to be practicing some problems like this, but I wanted you to see first how to do it. If you have the ability to print this out, that might be helpful. If not, maybe just save it somewhere so that you can access it, because it's very easy to forget these steps. You'll really need the steps for making a scatter plot and then the steps for a quadratic regression. We didn't talk about exponential regression, that's for later in the year, but I just kept it on the same piece of paper. And then a linear regression, you've done those before, but this gives you the directions on how to do a linear regression in Desmos. Okay, see you next class.